Welcome to the demo on deploying image inferencing server in confidential containers. This is a demo for Rejekts North America. So first step is to clone the repo, this demo repo, which has all the scripts for deploying everything. The next step is to deploy infrastructure and specifically deploying Azure Kubernetes service. For doing the deployment, we'll first export the resource group name and the SSH public key. Once you do that, you can use the make target deploy AKS to do the deployment of AKS cluster. It defaults, it takes the name that you gave before. It defaults to East US, and then the cluster name is also default called CAA Triton. Here you can see that on the Azure portal, the resource group is created and the Kubernetes service is also deployed or is being deployed. Uh, Going into it, you can see the status is creating. So it is deploying all the resources needed for the Kubernetes service. Once the cluster is deployed, the script downloads the Kubernetes credentials locally, creates the identity needed for the application, and gives you this DNS zone address that you can use for ingress later. It is also specified on this instructions page. Now we deploy key broker service, which will host our keys needed during attestation. It can be deployed anywhere, but we have chosen to deploy it in the same cluster. It has to be on the client side somewhere. Next, we deploy CAA or Cloud API Adapter. This is the project that helps us use confidential containers on public cloud easily. In this case, we are using Azure or Azure Kubernetes Service. Here you can see it has been deployed. It creates a runtime class in the end. You see these pods created in confidential container system. Now we'll do the client side preparation. First, we'll create a key, a symmetric key, which will be needed for encrypting the models. The next step is to store this encrypted key in KBS. Since we have deployed our KBS or key broker service in Kubernetes, we'll use the Kubernetes method of storing the key using secrets. And so just so that this key is loaded inside the KBS pod, we restart it. And we also export this KBS resource ID that we'll need later. You can see the KBS is restarted. So for the sake of this demo, I have loaded this sample model already in the repo. Ideally, you would want to bring your own model that you would that would train, and then encrypt using this make target. Remember the key that we created earlier? We'll use the same key to encrypt this model. You see that it is stored locally, and the script goes on to create the storage account, a container in that storage account, and uploads this model to that storage account. And in the end, you get this URL that you can use to download the model. Here you can see that the instruction also says encrypted file URL to be exported. Now, if we look at the Azure portal, you can see that the storage account was created for you by the script. And then inside the containers, this container was also created and the model uploaded is stored there. This is the exact same model that is available locally here. Now the next step is to deploy this Triton server, which will run as a confidential container. Let's look at the deployment first. Here we can see that the runtime class is Kata Remote. This is how we know we are deploying using Cloud API adapter. This init container is using an image which has logic to do attestation, download key, do decryption. That's why we provide KBS resource ID and encrypted file URL. The Triton server, this is the image we're using. Once the model is decrypted, it's stored in /data/models directory, and it's shared between init container and the final container. Finally, this ingress is exposing the service we saw earlier using the ingress name. You can run this make target deploy Triton server. Once it deploys, it creates this pod VM that you see. If you take a closer look at this pod VM in the security type section, you will see that it's a confidential security type. We can also see that it is deployed in default namespace, and on the other side, uh, we'll see like it has an init container which does the attestation and downloads the key after successful attestation. To verify, we'll see the logs of the key broker service, which released the key after it did the verification of successful attestation. All these bytes you see is evidence data. This is the request that it got. And you can see here that the attestation agent requested this key.bin from KBS. Here we are downloading the encrypted model, and here the key is used to decrypt the model and store in models directory. Now that the server is deployed, we can verify this is the same model that we had encrypted before. Now, before we start using this server, we need the client to be downloaded. You'll need Python for this. To be able to access the client, we also export the ingress IP of the Triton server, ingress URL, sorry. And to be able to use this, let's download a sample image of a cat from the internet. So here I'm copying the link to this image, storing it in a temp directory somewhere, and once it is downloaded, you can check like this is truly a JPEG image that we downloaded before. Now the instruction for using Python client and that cat image, you can run it here and see that after inferencing, it gives us the likelihood of what this image is about. We'll look at another example. This time we'll go with dogs, and let's pick one picture from here. In the same fashion as before, we'll download this image, store it in /tmp directory, and run the final instruction from the README using Python. Here you can see it gave us few results. Thanks for watching.